Okay guys, welcome to another video. This is our last lecture, and in this lab we will be covering counters. So what is a counter? It's basically a PLC instruction just like your timer, but the difference is the counter can count up or down. So let's say for example uh, we have a conveyor belt and we're counting the number of bottles that are passing by. So each time a bottle passes, the counter will go up. Another example is, let's say we have a parking garage and we need to track the number of cars. So when a car enters the parking lot, the counter will go up, and as a car leaves, the counter will go down. Let's say we have a number of cycles in, let's say the number of rotations of a shaft. So in any case where we want to do some counting, we can use counters. And there are three main types. So there are up counters, down counters, and up and down counters. So an up and down counter contains both counting up and counting down. So this can be used in the parking garage example which I explained. And just like your timer was represented by T0, T1 and T2 all the way to Tn, counters are indicated by CT0, CT1 and so on and so forth. Okay, so this is a counter instruction and it's quite simple. You have two possible inputs or connections. For the up counter, if you connect some, let's say x0 to up, every time x0 is high, the counter will go up by 1. So that means if I press this, let's say this is once, twice, 3 times, the counter's value would be 3. Now let's say I want to reset the counter. That means that if I press x1 and I connect x1 to this reset pin, the value will reset to 0. So that is basically how the counter works. And the down counter works exactly the same way, but the only difference is to count down. The only difference is the value of this counter will go down instead of up. So let's take a look of a basic up counter. Let's say we want to turn on output after some button is pressed 5 times. So what I will do is I'll go to my timer / counter at the very bottom of my program, and you can see up counter and down counter. So I'll drag the up counter over here and CT0. Now preset is what the threshold value is, after which the value of this counter will be high. So in this case, let's say I say turn on an output after button is pressed X times. So X is basically the threshold over here. Let's say that is 5. That means that once the counter reaches 5, CT0 will be high, and then I can use it for further logic in my code. So I'll drag an input over here. Let's call this X0. Let's drag another input, X1, to reset the counter, and I will drag CT0, which is what the counter addresses. And once the value reaches 5, let's turn on Y0. Now another way of labeling these addresses is that you can press F9 and you'll open up an element browser. So here you can go to X0, and let's say we want to assign X0 a name. So you can click on nickname, and I'll just say increment, and then I can press enter, and you can see that this is another way of giving a name to an address. So I'll press X1 and let's call this reset, because this will reset the counter. Now I can go to CT, so you can see that over here at the bottom, CT0, let's call this counter, and Y0, so I'll go to Y over here, and Y0, let's give this a name of motor, and I'll press enter. And now you can see that the names have been assigned. So this is useful when you're actually planning to know all of your addresses in advance. so that you can simply drag them and the value already appears. So I'll accept the changes and I will connect my PLC. And I will write to my PLC, and now I'll click status. Now you can see here that the value is not 0 by default, it's 6, and this is because I wrote a program and I had already worked with the counter. So every time you make a new program, the counter will remain its previous value even if you restart the software. So what I will do is, the first thing I will do is I'll run this program and I'll press X1, and notice that this accumulator value will change to 0. So I'll press X1 and the value resets to 0. Now let's take a look at this program. Every time I toggle X0, this value will go up because this is an up counter. So I'll press it once, I'll turn it off. I'll press it again, it's 2. Again, it's 3, 4, and 5, and once it's 5, Y0 will be on. Now, in this particular case, I have to turn it on and then off. But many actually physical PLC hardwares, you can simply press a button once, just to, like a flick switch. You press it once and the counter goes up. In our case, we have to press it on and then off. Now the value will continuously increase, and nothing will happen unless I reset it by pressing X1. Even if both are on, once I press X1, the counter will reset. Now let's say I want to use two preset values. So what I can do is, so let's say for example, once the value is 5, I'll turn on motor. Let's say the value is when the value is 15, I want to turn on some other motor. So let's say I want Y1 to be on. In this case, you can use greater than or less than, and you can use different comparison operators. So I'll use greater than, I'll drag it here, and now I can specify if CT0 is, let's say, greater than 10, then turn on Y1. So if I accept these changes, I'll write to my PLC, and now we can see that when I run this and I press this 5 times, Y0 is on, but notice that there is a check over here as well, and once this reaches 10, Y1 is also on, which you can see over here. So you can also use comparison operators for these types of things. Okay, so that goes through up counters, and down counters works in the exact same way. So I'll skip this just to save time in the lecture, but you can experiment with this. The only difference is that this counter will go down and this will decrease. Now let's take a look at a practical example over here. Before I do that, let me close this project, and I'll make a new one, and let's say practical task, and let me reconnect the PLC. Okay, so the task is, there's a grocery store and it wants to track how many items it sells per day. An item can be sold, so the counter would go up, or an item can be returned, so in that case the counter will count down. So in this case, we're performing both a up and down operation, so for that we will use an up plus down counter. Now the number of items should be tracked every 24 hours, which means that every 24 hours the value in the counter should reset. So how do we keep track of every 24 hours? So recall, in the previous lab we studied timers, and we will be using timers for this particular task. So let's actually do this first, since it's quite simple. So let's go to timer slash counter, and if you scroll at the very bottom, you can see up slash down counter, and this is the one which we want to use. So drag this over here, and it asks for two preset values, up or down. Now we don't really care about this, but let's say, for example, let's say we had a task, if we crossed 50 items, then perform X task, or if the items is less than 5, then generate some report. In that case, we would be using preset down and up, but we don't need that for now, so I'll simply press enter. Now notice that in the up and down counter, I can connect one input for up and one for down. So I'll drag one over here, and I will say, let's call this item sold. That will be X0. I'll drag another input, let's call this X1, and I'll press F9. I'll go over here, I'll call this X1, and let's say this is item returned. Okay, so I'll drag a reset over here. Actually, let's leave the reset for now. Okay, so what this will do is, when an item is sold, or if X0 is high, this value will go up, and if item is returned, or if X1 is high, the value will go down. Now we need to reset this value every 24 hours. So here we have a reset, but how do we do that? So first we'll need a timer, and we'll use an on delay timer. So I'll go on delay, and we'll set the threshold to 24 hours. I'll press enter, and so what will happen is that once 24 hours pass, T0 will be high, so I'll call this T0. Now there is one issue. Once 24 hours pass, T0 will be high, but it will remain high because the timer does not reset. So in order to fix that problem, we need to cycle the timer. So once it reaches 24 hours, it should reset so that the items can be tracked for the next day. So an easy way to do that is to get a normally closed contact, drag it here, and we'll call this T0. And what this will do is that this will make the timer reset every 24 hours, or whatever the time is specified over here. Now 24 hours is too long for us to test in this class, so I'll simply make this let's say 20 seconds. So every 20 seconds the timer will reset, and it will also remain high briefly, and when it remains high, it will reset this accumulator. So I'll write this PLC program, no errors, and let's take a look at what happens. So I'll run this, and let's turn on the status. So you can see it had some value of 10. So the time reaches 20 and it resets, and the value resets. So let's say I sell an item, so the value goes up. If I return an item, this value goes down. And let's wait for this to reach 20 seconds, and you can see that once it reaches 20 seconds, the accumulator resets back to 0, and a 0 flag is high over here because the value is 0, but I can always change that by selling an item. So this is quite simple, but it's actually it's not very long. It's only 2 networks long, but it performs quite a useful task. Now obviously there's no data logging over here. We can do that with a log over here, but that is outside of the syllabus, so we will skip that for now. So that's it for this lab, but as usual you have an assignment. It's due the following week, and the assignment is quite simple. Basically you have some sort of safe So here let's say you store something valuable and there is a lock, there's a locking system, and you have to design the PLC program for this locking system. Now what exactly is this locking system? Take your roll number and take the last three digits. So in this case you have 1, 2 and 5. So what you have to do is these 3 digits will represent a sequence where you have to press one button, X0 one time, you'll press X1 2 times and X2 5 times. So that is the sequence. So what you have to do is, for example, you press this once, you press X1 twice, so once, twice, and you press X2 5 times, so 1, 2, 3, 4 and 5. And once you do that, you press a fourth button to activate the code, so X3. So once you've pressed your sequence, you press the activate button, and that will do 2 things, which is mentioned over here. So button 4 will be pressed once to activate the code. If the code is correct, you will activate Y0 and Y1. So if the sequence was correct, so 1, 2 and 1, 2, 3, 4, 5, then I press X3, and if the sequence was correct, Y0 and Y1 will be high. If the sequence is wrong, Y2 and Y3 will be high. So hopefully that makes sense. So this is how it should work. So let's say, for example, for the same exact roll number, so let's say your roll number is 1745125. 125 is your code, which means you press X0 once, X1 twice and X2 5 times. Then when you press X3, Y0 and Y1 will be high. Here is an example of an incorrect sequence. In this case, X1 is pressed twice, and then X0 is pressed once, and X2 is pressed 5 times. So this is actually in the incorrect order. So when X3 is pressed, Y2 and Y3 will remain on. So if that is confusing, I will make a video showing how the task should look like, so you can watch that video as well. But this is your task, and that's it for this video.